What's up, guys? I got a full hour of sleep last night after the baby was born, so I'm feeling charged and ready to go. It means it's time for some algebra. So here we go. We're going to continue on finishing section 1. We learned the basic exponent rules on for pages 1 and 2. We went over. You should have all the skills you need for section 1 done. Okay, now we're going to move on to section 2, which is 2, and that's like A through E or something, okay? And so the main two skills you're going to need, or the main two rules you need to complete the problems from section 2 are knowing kind of what a rational exponent is and being able to find the value of something with a rational exponent. So rational exponent means a ratio in the exponent, which is a decimal or a fraction, right? So 9 to the 1/2. You need to know. You need to know what this has value. 9 to the 1/2 is what? Okay, and it really is the square root of 9. They mean the exact same thing. 9 to the 1/2 and the square root of 9. On an iPhone, you don't even have a square like the square root button that looks like this. You've only got the one with the little 2. Well, it turns out they're the same thing. These are all equal, and they all ask the same question. They ask the question, what number multiplied 2 times is equal to 9? And of course, that answer is 3. All of these mean the same thing, and you need to know that. Okay? The important thing being here that whatever's in the denominator ends up being what's called the index. This is the index of the root. Okay? The general case rule is x to the 1 over n is equal to, it's an n, the nth root of x. And the most important thing here is you being able to know what question that asks. This asks the question, what number multiplied n times is x. Okay, right here. What number multiplied 2 times is 9? 3. 3 times 3 is 9. There it is. Sweet. Okay, so then you guys should be able to answer the following. 49 to the 1/2 is, what number multiplied 2 times is 49? The answer is 7. Okay, or how about, let's see here, 8 to the 1/3. What number multiplied 3 times is 8? The answer is 2. Great. Those are all cases where the numerator is 1. Turns out another rule you can have, but not all ratios have a 1 in the numerator. You could have one that looks like so, like 27. Let's do this one. Let's do 8 to the 2/3. This one's a little bit different. Okay, 8 to the 2/3. There's multiple ways you can tackle this question. So here's our first rule. Let's kind of box that there. Get used to this pad, this kind of trackpad thing that I'm using, which is a little weird. Okay, the second rule is x to the m divided by n is equal to the nth root of x to the m. It's also equal to the nth root of x, all raised to the m power. Okay, both of those, in this case, you make whatever number it is bigger, and then you make it smaller with the root. In this case, you're making the numbers smaller by taking the root first, and then making bigger by raising them to a power. So, let's take a look here. Which one works better for 8 to the 2/3? Let's try both. All right, let's try this first one, the nth root of x to the m. Okay, so let's see. N is in the denominator, so that goes on our root. So 3 goes on our root. So we're taking the cube root 8, and then we raise 8 to the second power. Cube root of 8 squared is the cube root of 64. What number multiplied 3 times is 64? Well, you guys would look at that chart at the front. It's 4. Actually, you probably have to use a calculator there. Great, 8 to the 2/3. The other one, right here. Okay, the other one is the nth root, which is the third root of 8 squared. Now, the third root of 8, this asks the question, what number multiplied 3 times is 8? On the inside of the parentheses, and that, of course, is 2. We already know that from above. And 2 squared is 4. So I think that actually this method right here is easiest for evaluating. Okay, so that's the one that I think is the easiest for evaluating. Turns out you can also use this rule when trying to write in 2 different forms. So remember that rule, write the rule one more time, or I'll at least write 1/2 of it. X to the m over n. Do you need me to fix the bottle? Sorry, guys. I got a baby here on the line. What can I do? Man, I got a whole new set of problems to solve. Here we go. So I'm going to do the nth root of x to the m. Okay, this right here is called exponential form. That should make sense because we're indicating its value with the exponent. Okay? And this is called radical form. That kind of swoopy symbol is the radical. Okay. So on number 3, these are for question 3. So 2, we were kind of starting here and kind of going there to evaluate. In question 3, all I'm asking you to do is you're starting here, and I want you to write it in this form. Okay. So let's see a couple of examples. Oh, you know what? There was one more I wanted to do. Let me go back to that really fast. Let me go back. We're going to extend the page. Okay. I wanted to do one more here. Let's take a look. We'll come back to that in just a minute. 49 to the 3 halves. 49 to 3 halves. Okay. Let's make things smaller before we make them bigger, which means we do the square root of 49 and then raise the result of that to the 3rd power. Square root of 49 is 7, so this is 7 to the 3rd, which is, oh man, that's a big number. I think it's 343? 343, that seems right to me. Okay, 343. Great. Now, if someone gave you a question that looked like this, what's 49 to the 3 halves minus 110? Okay, people are inclined to try and subtract these two first, but you shouldn't. Order of operations states you have to deal with exponents before you deal with addition or subtraction, or multiplication or division for that matter. So to evaluate something like this with an expression that's got an exponent, you would find the value of this first and then do the subtraction later. So we would do 343, because we know that, minus 110 is equal to 233. So 233 is the value of 49 to the 3 halves minus 110. Okay, back. So if you see those multiple ones, simplify first. Great, exponential and radical form. What question 3 is asking you to do is it's giving you a radical. So it's saying, hey, look, what is the square root of x to the 3rd written in exponential form? So we're starting with this, okay, and we're going to that. So let's take a look down here. What is the, I always look, so it's x is the base, right? You got a numerator and a denominator. The denominator is whatever is inside the root is m, or sorry, the denominator is whatever is the index. In this case, it's nothing there, so it's a 2, square root, okay? Whatever's the exponent here is a 3. I'm sorry, I Can't help you, Megan. I got to finish this.
I know.
Okay.
I'm just
Thank you, everybody. Oh, there's a lot going on. Here we go. All right, there's the first one. All right, and B. Part B. That was example A. So that's it. All I want you to do is write it in exponential form. Boom. Sweet. Right down here. Let's do another one. The cube root of m to the 7th. Okay. Take whatever's on the root that goes in the denominator. This is m to the 7 over 3. Okay. If the final's multiple choice, it's going to have them mixed up. So just make sure you remember which one's which. And C. The way that I remember, by the way, so you guys don't, is I think about this. If I can remember that 9 to the 1/2 is the same as this root of 9, right? If I can remember that, I know that the denominator goes in the index, so I always know that this thing goes down in the denominator. That's how I remember, is just that one rule. Okay, and so you guys should be able to practice and say this out loud. What is the 6th root of x to the 5th in exponential form? It is x to the, that's right, 5/6. Cool. All right, that's number 3. Now moving on to number 4, which is probably the longest and most arduous of these. So let's hop to it. Okay, first you need to know, everyone I think can do something easy like the square root of 100. Square root of 100, what number times itself 2 times is equal to 100? The answer is 10. Great. Now some of those are a little harder. I gave you ones like the square root of 50. Well, 50 is not a perfect square. That's a problem. So what we've got to do is we've got to break 50 apart into a product of a perfect square and a not perfect square. And many of you probably already know that it's 25 times 2. Okay, moving the bottle. I'm going to move that for you. I'm going to reposition that for you. One step at a time. Okay, which one's a perfect square? 25. Okay, so we break that into a perfect square. 25 times a not perfect square, 2. This in simplest radical form is 5 times root 2, because the square root of 25 is 5 and root 2 just comes down. The most common mistake I see people making is they take the square root of 5 and then, or 25 and then leave it under the root. As you take the square root, as you answer that question, what number multiplied 2 times is 25? The root must disappear once you answer it. Okay, so that's kind of the first basic step there. And so let's move on to ones with exponents. What if you have one that's like the square root of x to the 10th? Now, 10 is not a perfect square, but you got to know that there's a big difference between the square root of x to the 10th and the square root of 10. Those are two very, very different questions, and they're not equal. So I should have done that first. These things are not equal in any way, shape, or form. Okay, that's like saying 3 squared is equal, or yeah, the square root of 3 squared is equal to the square root of 2. No, just no. Okay, so none of that mumbo jumbo. So the square root of 10 is what number multiplied 2 times is x to the 10th. And by that I mean some number times some number gives us x to the 10th. That number is, well, guess what? You can just use that rule from before. This is x to the 10 divided by 2. You just divide the index, and you're going to get x to the 5th. Or that basic power rule, x to the 5th, you add their power, so naturally you would have this to figure out what those two things multiplied are. Okay? If this was a 3, you would do it 3 times. All right, cool. Let's see here. All right, so that's kind of a separate example there. Let's draw a line. Okay, and then let's do another one down here. What about ones that look like the square root of x to the 13th? The square root of x to the 13th, well, 13 is not even, and it's so you can't just divide and get 6.5. That's not helpful. Okay, we want it in simplest radical form, And you're going to have to do the same thing you did with 50. You break it into the product of a perfect square and a not perfect square, so you peel one off to get x to the 12th times x. This is a perfect square. What number times itself is equal to x to the 12th? That is, so you take the square root of this, square root of x to the 12th. Need help? Okay. You just, okay. I'm sorry. I'm getting in trouble here, guys.
Just don't say that.
Okay, square root of x to the 12th is x to the 6th. Okay. This guy is passed out. Too much milk. Okay, let's see here. All right. Man, I bet this is a lesson you guys never had before. Newborn baby at the lesson. He's going to have his exponents down. I think you could say that for certain. All right, let's move on to cube roots. Okay, so you take the square root of the things that you can. The square root of x to the 12th is x to the 6th. Cool. Next one. Okay, for cube roots, let's try one like this. The cube root of 16. The cube root of 16, notice it is not a perfect cube. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So what you do is you break 16 apart into the cube root of 8 times 2 because 8 is a perfect cube. And so then you can separate the root. This is the cube root of 8 times the cube root of 2, which is 2 times the cube root of 2. Okay, this was the thing I could take the square root of. Same process. Same process. And then with numbers, again, if you just have like the cube root of x to the 12th, you can use that power rule. 12 is divisible by 3, so you can say, oh, that's just x to the 12 divided by 3, x to the 4th. What number multiplied 3 times is equal to x to the 12th? All right, well, blank times blank. Does that make sense? Is that something that I agree with? This is a question, right? Yeah, the answer is x to the 4th. 4 plus 4 plus 4 is 12. So you really don't even need to do this thing right here. That's, the step above is preferred. Super. Okay, last one. Let's do some more peeling off. The cube root of x to the 14th. And I said the last one, that's not true. We've got at least 2 more I gotta do. Cube root of x to the 14th. 14 is not divisible by 3, and if you peel one off, 13 is not divisible by 3. So sometimes you end up having to pull off more than one x depending on what this index is. So you have to do x to the 12th. You want to get down to the 12 because 12 is the first number you're going to hit, whole number, as you pull off x's that's divisible by 3. Okay. Now I can take the cube root of this. I can't take the cube root of that. So you take the cube root of the thing you can. What number times itself 3 times is x to the 12th. X to the 4th, we already know that from the step above. And then you have left over times the cube root of x squared. I could not take the cube root of that, so it remains under the root. Fantastic. So let's do some larger ones. I would say this is probably the most important example I'm going to do. Right here, the cube root of, let's see here, 64 times x to the 21st. What number multiplied 3 times is 64? And what number multiplied 3 times is x to the 21st? Well, you think about them each individually. That's a perfect cube, and so is that, because 21 is divisible by 3. Okay, so the cube root of 64 is 4. The cube root of x to the 21st is x to the 21 over 3, which is x to the 7th. And it's as easy as that. Both of these were perfect cubes, so you can simplify it and write it as such. And then the last one, 20 x to the 8th. Cube root of 20 x to the 8th times y to the 15th. Okay, great. This is a square root, not a cube root. 20 I cannot take the square root of, so I have to break it apart into the product of, class, go for it, what do you think it is?
4 times 5.
Yep, that's right. Wow, nice job. Okay, 4 times 5, 8, is x to the 8th a perfect square? Yes, because it's divisible by the index, which is 2, so that stays the same. So far, we've got 4 is a perfect square. We've got x to the 8th is a perfect square. Y to the 15th, is 15 divisible by 2? Nope. So how many do we have to take off to make it so? Just 1. You're left with y to the 14th times y. Continue my root. Super. This is my perfect square. Okay, so I am going to take the square root of this, this, and this, and leave the 5 and the y underneath. You end up with the final answer of 2. X to the 8 divided by 2 is 4. Y to the 14 divided by 2 is 7. What's left over is 5y. Okay, that's it for your review on part 1. The reviews for part 1 and part 2 are on the website. Solutions will be posted soon for you to check. Thanks for watching.